Alright, we're going to combine what we saw yesterday about similar triangles with some new work on similar polygons, but the concepts stay the same. This concept of similarity is based on two things, just like we discussed yesterday: corresponding angles that are equal and corresponding side lengths that are proportional. Two things we're going to look for here. So in this first example, we're given two quadrilaterals and we're just asked, are they similar? So we're going to look for angles and we're going to look for sides. The first angle we see here is the top left corner, and we could just call this angle M, or we could call this angle AMH more appropriately, but that is equal to 90 degrees, so this first corner is equal to 90 degrees, and that corresponds with angle M prime on the other side, which is equal to 90 degrees as well. So we see that those, whoops, I should have written it down here, sorry. And angle M prime is equal to 90 degrees as well. So the first kind of set of corresponding angles check. And notice when we say corresponding, we're talking about angles in the same position on the two figures. Angle H and angle H prime, these guys over here is our second set, both equal 90 degrees. Angle A and angle A prime equal 100 degrees. And the last set is angle T and angle T prime, and they both equal 80 degrees. So for pairs of angles, all corresponding angles are equal, so that checks. The next thing is the sides. We're going to compare the corresponding sides here. So, and we're looking for proportions, right? We're looking for sides that are proportional. So if we talk about MH and MA for a minute, MH over MA should be proportional to M prime H prime, this guy, over M prime A prime. And if we put in our numbers, 3 over 1 should be proportional to 4.2 over 1.54. Well, how do we check that, right? Because now we have all the information. We're not really setting up proportions. What we can do is we can just kind of break it down. We can look at it a little differently, right? Setting up our proportion like that doesn't help us out. What does help us out is to think about this: MH over M prime H prime. Now we can talk about we can talk about it in a different way. And actually, I'm just looking at the numbers here, and I'm realizing this would be 3 over 4.2, which would work. And we can do the math here. So that equals 0.71. And we'll see that for every pair, if we start adding them up, we can look at M prime A prime, MA over M prime A prime. We get that that's 1.1 over 1.54. And again, we'll check that on the calculator. It should be equal 1.1 divided by 1.54 equals same thing, right? And we can check that for all pairs. A over T, 3 over 4.9, right? 3.5 over 4.9. So those sides should be equal to the same scale factor. We're going from the small to the large, and this number then is our scale factor. We could do the same with HT, 1.5 and 2.1. H prime T prime equals 1.5 over 2.1, and if we do the math, we get the same number, we get the same scale factor. So that means all our sides are proportional, right? This is going to work every time because it's always equal to 0.71. All right? All right, jumping ahead, let's look at some trapezoids. And now we're told they're similar, and now we're trying to use that similarity to find the unknown sides. So we're not going to worry about angles. What we are going to do is we're going to compare corresponding sides, right? Our green tops should be similar, and our blue right-hand side should be similar. So we can set up this proportion in a number of different ways. I'm going to set up like this. 1.6 on the top over 2.4 on the top should be equal to 1.2 on the right over the thing we don't know on the right. And notice we're also doing this. This is, whoops. We've got the top of number 1 and the right side of number 1. The top of number 2 and the right side of number 2. So we've got our tops together on this side. We've got our right sides together on this side, and then as we build our proportion, we've got trapezoid 1 on the top and trapezoid 2 on the bottom. Okay, so you're thinking through how you're putting together that proportion. Once it's set up, the solution is easy. We just cross multiply and divide. 2.4 times 1.2 is the cross multiply piece, divided by 1.6 is the divide piece. That gives us 1.8. So for the side length, right? The unknown side is 1.8, and it would just be units in this case because we're not given centimeters, inches, or anything like that. We set up a proportion and we solve. Make sure you understand where those numbers are coming from. Make sure you understand how to do the math. We cross multiplied this way, and then we divided by this. That was left over. Lastly, you're going to see some figures and diagrams and shapes just set up differently. This could, for example, be like ladders on a building, and you're trying to keep them proportional. This could be something you're designing and creating. You want to use similar figures. So it says explain how you would find out if these two are similar. And then assuming they are similar, find the unknown side. Your finding out might be measuring angles, perhaps. So you get out a protractor, you might measure some angles. Second way you could find out is to check corresponding sides. Right? See if the corresponding sides are proportional. B tells us then, assuming they are similar, now find the unknown side. So what I'm going to suggest you do here in a diagram like this is actually just pull these apart, right? Sketch yourself the two separate triangles, because what they're giving you is they're giving you this side length of 22, but they didn't give you this. They did give you the 4 and the 6, so you know that this is going to be a total of 10, but it's not given to you. So that's why I suggest you kind of pull apart your diagram so you can see the pieces and you can see the two triangles you're actually working with. This little guy has a base of 4, and he has a left side that is unknown. So now we can set up a proportion, we can solve for the unknown. We've got base on the small is 4, divided by 10 as the base on the big. That'll be proportionate to question mark left side of the small over the 22 left side of the big. Right? So we got base over here, we've got left over here, we've got smalls on top, got bigs on the bottom. That's how we set up a proportion. You might set it up differently, but you should end up doing this. 4 times 22 divided by 10 to get your solution, which is 8.8. So this side length is 8.8 units long. Alright, make sure you're looking. In every case, make sure you're looking to see kind of what you're working with, what the unknown is. You should have 3 things you know, 1 thing you don't know, and make sure you're thinking about how you're setting up your proportion. If you can do that, then the solving's easier. You could be cross-multiplying and dividing every time, or you could be kind of looking for the multiplier, right? And you could be using that times 2.2 to solve every time. Good luck.